Okay, so in this video, Dr. Shang will show you how to generate dot plot, histogram, and process capability index using the clench plate thickness data. So the data is available on the blackboard under the file name clench plate thickness.mtw. Okay, so you can open it. Now if you open it, you can see the first column corresponding to the 30 subgroups that we have, and then column 2 to column 6 corresponding to the 5 examples we take from each of the subgroup. So for example, subgroup 1 has 5 examples. The first example is 0.0624, the second example is 0.0626, and so on and so forth. Now column 7 it calculates the sample average, the X bar, and the column 8 calculates the R, which is the maximum value minus the minimum value within each subgroup. So for example, for the first subgroup, the maximum value is 0.0627, the minimum value is the sample 1 and sample 3, which are 0.0624, so difference is 0.0003, which is recorded as R. Okay, so column 10 corresponding to the same 150 data points, but they are just reorganized in one single column. So the first 5 number corresponding to subgroup 1. So you have 0.0624 as the first sample. The second example is 0.0626. Now if you look at the sixth example, 0.02624 corresponding to the sample 1 in subgroup 2. Okay, so this is just another way to organize the data. Now let's see how can we generate the dot plot. Now go to graph, dot plot, click it, and they give you several options. Let's just go with the simple options, the default, and then hit OK. Now it will ask you for what are the variables that you want to graph. Let's say that we want to look at all samples, and we hit OK. Okay, so we will get our dot plot, and if you double click on the x-axis, you can change the range. So let's say the minimum value you want it to be 0.0620, and the maximum value you want it to be 0.0632. Okay, so you can change the range. Now you can also generate another dot plot. This is when you have all the data. Now if you want to look at the distribution, the dot plot for the sample average, which is X bar, you can just choose the graph variable as the X bar. And again, you can change the range by double click the x-axis, change this to, and change the maximum value, so that you can easily compare the average with the all the data points. Now you can plot both of them at the same time. Okay, so if you hit OK, and first you plot X bar, and then you plot all sample. Right, you can plot them at the same time, right? Okay, so this is how we generate the dot plots. Okay, so to construct histogram, you go to graph, histogram. There are 4 different options. So if you go with the width, fit, and groups, and hit OK, here you can select which variable that you want to graph, sample and x bar. Okay, so you can play with if you check this or not. So if you check this, the two plots will overlap on each other, the two histogram. So it will just show one plot. If you uncheck this, it will show two separate plots. And then you can also check the scale. So for example, the Y scale type, there's three different options. So what we use is the frequency, okay, and then OK. Okay, so here is the histogram for all samples, which is denoted by the blue curve, and the red dash corresponding to the sample average x bar. So as you can see, the mean of the two curves are the same. So the all sample and the average sample average should be the same as expected. But in terms of standard deviation, the standard deviation for all samples are slightly larger than the one for the sample average as expected. So finally, N is we have 150 points for all samples and 30 points for the 30 subgroups when we calculate the sample average. Thank you. Now let's take a look at how can we generate a process capability. Go to Stat, Quality Tool, Capability Analysis, and Normal. Okay, so often we will assume the data points they're normal. Now, so you can see there are two options. One is if it's all the data is in a single column, like in column 10, the subgroup size you need to specify. So in our case, it's 5. So this is one way. Another way is you can choose subgroup across rows. So we already set it to corresponding to the 5 samples corresponding to column C2 to C6. Okay, then we can hit OK. And it will ask you that you did not specify any lower or upper specification limit. Okay, so let's go back, right? Go to option. It will says the target value, target specification, right, which is 0.0625. Okay. If you go to estimate, and you can see here the lower specification and upper specification. So the lower specification, our example is 0.0622, and the upper specification is 0.0628. Okay, and then the others are optional, so you hit OK. Okay, so it will generate probability process capability report. Okay. So we need to rearrange a little bit so that you can see it. Okay, so we can see here is the process capability report. Okay, so we can see this part that indicates the process capability. So we already calculated those values before. So the CP is 0.71 and the CPK is 0.33. And we can see that the red curve, so the legend, we need to enlarge the legend. Okay, so we see that the red curve is the overall data points, and the blue dashed one corresponding to the sample average. We can see that the process is not centered around the target specification, and also it's not capable. So here the ppm is similar to the DPMO, so that's the defects per million opportunities. We can see the overall, so the total will be about 292,912. Okay, so we can say that the process is not capable. Thank you.